Hello everyone, we're going to look at some questions where we're trying to calculate the arc length, but the algebra kind of fails us at the end. And so we won't be able to get an exact value for the arc length, and we have to end up essentially using our calculator, this guy here, to get an estimate for it. So first example of this happening was question 6. We have a space curve with a pretty nondescript space curve, nothing too unusual about it, evaluated from 0 to 4. Well, we know how to get the arc length. It's integral from 0 to 4. This guy's derivative squared plus t cubed, which is what, 3t squared, and this one at the end, 4t cubed squared. So the integral from 0 to 4. Okay, that guy is essentially 4t squared, 9t to the 4, and 16t to the 6. And although that might look like it's a perfect square, which very often it would be in a good question, this one is not. In fact, we can't do anything except get the answer by using the calculator. So this is what I'm going to do. So I'm going to do y equals, and we're going to put in the square root of 4t squared, which becomes 4x squared, because we don't have t buttons, 9t to the 4, 9x to the power of 4, and 16 x to the power of 6. And that's the guy. I'll do the window from 0 to 4, and I'll do a zoom 0. And that's just a way of checking that I haven't done anything weird here. And something is getting drawn as we speak. And now I can get the answer to the integral, which is what we want. So it's choice number 7. Lower limit 0, upper limit 4. And we should get 265.6. We get 265.67 to 2 decimal places. And that's essentially all you need to do. So let's try question 7 then. We have a space curve. It's got some trig in it. It's got the cosine of pi t. It's got a 2t in it. And it's got the sine of 2 pi t. So we know the arc length is going to be the integral. Well, let's see. Well, in this question, they're a little bit sneaky. They don't tell us where the t value starts or finish. They tell you the coordinates of where it starts and the coordinates of where it finishes. But they don't tell us the t values that corresponds to. I would use the middle one. Well, if the middle one is 0, that makes t equals 0 as the start value. And the middle number is 12, so that makes t equals 6, the destination value. So now we know 0 to 6. And we can do the square root of, well, when you differentiate cosine of pi t, you get negative pi, the sine of pi t, and then you square it. And you differentiate 2, and then you square it. And then you differentiate the sine of that guy and get 2 pi cosine 2 pi t, and then you square it. So it's going to be the integral from 0 to 6 of pi squared sine squared pi t plus 4 pi squared cosine of 2 pi t. And it's a cosine squared, of course, is 2 pi t. Again, that is not going to work as an exact value. There isn't a use of or anything like a perfect square that's going to help us. So we simply just go to our calculator and we're going to y equals, little bit messier to do this, but it is possible. Square root pi squared. Just make sure I hit the right one there. Pi squared. Now to get sine squared pi t, you have to do a bracket. So put the bracket, then do the sine, in this case of pi t, call it pi x. Then close the brackets and square it. And that's how you get that guy. Plus 4 pi squared. Now you get the cosine, do another bracket, put the cosine inside the brackets and 2 pi t, which becomes 2 pi x in our case. Close that bracket. Now we can square the cosine. Then we finish by closing that bracket. And I think that's enough brackets. So I'll do here, put in 0, and then 6. And then I'll do a window, 0, 6, sorry. Then I'll do a zoom to fit. So zoom 0. And we'll see what this guy looks like. It's a very haphazard, multiple kind of curve thing that's going on here. Now I'm going to go second calc and do option 7. The lower limit is 0 and the upper limit is 6. And I'll hit enter. And just wait a little while because it's going to take a fair amount of time because it's quite a big calculation. It should be 30.9934. You can see it in this darkness, but those little dots at the side are telling me that it is still working on it. So it's probably the fact that there's such a complicated function, there we go, that it's taking its time to evaluate it all. And now you get 30.9934. And that's the answer to 4 decimal places. And that's how you use your calculator to get arc length when the functions themselves are not algebraically pretty. Not very nice.